x for minus of y and y for minus of x. Then if the equation of the curve is unchanged, then the given curve is symmetrical about y is equals to minus of x. Last property, symmetrical in opposite quadrants. These are known as quadrants. This section, this is like first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Okay. So if you're going to interchange x for minus of x and y for minus of y, then the given function and then the given curve is symmetrical in opposite quadrants. Let us look at the examples straight away to understand. So this is about symmetrical about x-axis, and this is the curve which is symmetrical about y-axis. This is the y-axis, and you can see the curve is symmetrical. And this symmetry is very rare, very rare. The symmetric about y of y is equals to x. This symmetric about y is equals to minus x. This is the straight line y is equals to minus x itself. Next example is also y is equals to minus x. Symmetric in opposite quadrants. Look at this. Okay, is this clear about symmetry?
Yes, sir.
Yeah, Rishi, do you have any doubts from the previous class? Do you know what ChatGPT is?
Yes, sir.
So tell me the full form of GPT. Anywhere?
No, I have no idea about it.
Okay. No problem. You just have to go on ChatGPT and ask GPT to draw y is equals to x, y is equals to minus of x, y is equals to x square, and minus of x square. All these curves and observe how they are drawn, because they will be useful when you will be tracing the curves. Okay. And so while solving question, they'll help you. And also learn about the graph of straight lines, parabola, and circle. Follow chapters and CRT also sometimes. I'm also going to explain straight line, parabola, and circle to you. So first, let us discuss again about straight line a little. Okay, straight lines have, as I have told earlier, they have linear equations, and like the general form of this equation is this, where y is just a variable, x is also a variable, and they will remain like this. Okay. In equation also, only y and x will be some variables, c will have some value, constant value, and m will also have some constant value. M is the slope of straight line, and c is the intercept of line on y-axis. So if we draw a graph, and if there is a straight line which is touching y-axis, so on that point which it is touching, the x coordinate will be 0, and there will be some point on y, like this will be some point c. So this is known as the intercept of y on y-axis, that the line is touching the y-axis on some point which is represented by this. And the slope, like if this is theta, slope of the slope of this is tan of theta. But we can also find out the tangent, and we can also derivate the function dy by dx is also the slope. And we can also find out the slope of the straight line by using del y upon del x. That is basically change in y, change in x. Okay. So, and it is always the theta is always calculated from the positive x-axis. And in an anti-clockwise direction, angle is always calculated positively in anti-clockwise direction, or you can say counterclockwise. And angle will be negative if it is uh, calculated from positive x-axis in clockwise manner. So then it will be considered as a negative angle. Okay, so this is a lot about straight line. If you have some equation like y is equals to 2x plus 3, then simply for drawing that equation on graph, what is suggested to do is that simply put values of y and x. 2 points are enough to find, like first put y is equals to 0 and then calculate for x will be minus 3 by 2, and put x is equals to 0, then y will be 3. So just okay, okay. Let us say this is our graph. 1, 2, 3. Same also this side. Okay. So y is 0. So y is 0 here on this. Sorry, on x-axis y is 0. This is positive x, this is positive y. I hope you understand. For y is equals to 0, so y is 0 on whole of the x-axis. X is equals to minus 3 by 2. This is minus 1, this is minus 2, minus 3 by 2 will be somewhat here. So this is one point of straight line. Let us call this point A. In the B point, y is x is 0, so x is 0 on y-axis. X is 0 on y-axis. So y-axis when y is equal to 3. So this is B point. Simply just a straight line will be passing through these 2 points. Okay. Now this is the equation of straight line y is equals to 2x. Similarly, you can uh, trace any straight line using this technique. Is this clear to you?
Yes, sir.
It is very easy. We have also done it in junior classes. So this is about straight line. Let us now discuss about circles. So here you can also see there's a circle. Circle is what? Can anyone tell me? Define circle. Yes, this is how we can define it. That there must be a center and the locus. Locus means we are tracing all the points which are equidistant from a certain point, which is known as a center. And if we we take all the points which are equidistant from the center. So when we collect all those points, when we collect all those points, then it will be a circle. Let me take help of technology. This is a circle. Yes, this is a circle in which there is a center, and center is equidistant from all of the point of the circle. Okay, so if we call our centers coordinate as h and k, and if it is if it have radius is r, so the equation of circle will be represented as x minus h plus y minus k square is equals to radius square. Okay, and if the center of the circle is on origin, like if the center is on origin, so h and k will become 0 and 0, right? So the equation of circle can be represented as this. This is the general form, and this is also very useful. Right? These are both are equation of circle. Okay. Is this clear to you, everyone?
Yes, sir.
So this is about circle. Now moving ahead. So here you can see center is on H and K, radius R, and this is the basic general equation of conic which represents circle. You will discuss further more about this in conic section chapter. Equation of this. Okay, so this is about circle. Done it. Let's discuss about parabola. So simply writing parabola is as straight lines had equation of degree 1, parabolas are all the curves which have degree 2. They have degree 2. Okay, so it can be like in this format, or sorry, or in this format. Okay, so these can be, sorry, little bit wrong. Y square equals to 4ax, so x equals to 4ay. It can be in any different formats. Basically, parabola is a curve like this. We'll understand more about it here in this. So as you can see, this is also a curve. Y square is equals to 4ax. Now, what decides whether the parabola will be facing positive x-axis or negative x-axis or positive y-axis or negative y-axis? Basically, let's observe this equation. Y square is equals to 4a of x, and a will always be positive. It will always be positive. So now if we consider for x like y square by 4 is x. So now for any value of y, x will always be positive. So that's why all of the curve, all of the graph would be on positive x-axis side always. So that's why it will face positive x-axis. If we will observe this, so y square upon minus 4 is equals to x for any value of y. For any value of y, x is always going to become negative. So that's why this is facing negative x axis. Okay, is always having some negative x value. And for this, and except for y is equals to 0, where x will become 0. Okay. And here, as you can see, for value of y will always x square by 4a. So for all values of x, doesn't matter. For all values of x, y would always be positive. That's why the parabola is facing positive y-axis. Same goes for this, y is equals to minus of x square by 4a. So for this is a. This is for all values of x, y is always going to become negative. So for all values of x, that's why the parabola is spreading through all of the x-axis, and it is always a negative of y. The our output of the function is coming out as this. So that's why the parabola is facing the negative y. Is parabola clear to you?
Yes, sir.
Yeah, and note that a is some constant here. It will be some number, and here it is represented as focus. Okay. We'll learn about more in the chapter of conic section ahead. You just have to understand these equations and where the parabola is drawn for this particular chapter. So if this much is clear, then you're good to. So understand these two terms also, lattice rectum and directrix. If this is the parabola having focus, so a straight line drawn like this and x is equals to minus of a. There's a correction in this. And the photo credit goes to QMath. So x is equals to minus of a. This line is drawn perpendicular to lattice rectum away from to a distance, and this lattice rectum is drawn here in the focus, touching the parabola on the both sides, and its length is 4a. That doesn't matter. Okay, just you have to understand what is latus rectum and what is directrix. If this much is clear to you, then you're good to go. So a circle we have already discussed. Ellipse is just stretch format of a circle in which the a square and b square is also there, where a is the radius of major axis and b is the radius of minor axis simply. And there are also cases of ellipse. You can see it. Sorry. So if B is larger, like this major axis is on y-axis, so B will be here B will be larger. Okay, so you can see this is focus and this all you just ignore them. Just learn about the graph that if A is greater, the A when A is the number which is with x, so the graph is going to be drawn like this, and if B is greater, the graph is going to drawn like this. These two things only you have to learn for this chapter particularly. So is ellipse clear? Yes, everyone.
Yes, sir.
Also learn about the focus. Focus will be somewhat here. And for this kind of axis, it will be on y-axis focus 0 plus minus of a. And you also have to remember the eccentricity of this. So eccentricity of ellipse is written here. Should be b by a, something like that. Let me confirm. Here is the eccentricities formula. But as far as I know, and as far as I've seen, there are no particular questions very much related to this, but please be on safe side. And we are going to learn them after all in our corner section chapter. Okay. So if you don't want to learn them now, no problem. Just understand the graphs and just learn to recognize the graph after seeing the equation. So, okay. So let's now move ahead with the basic things that if you have to find out the intersection of the curve with origin, then you have to simply that if any equation of curve having constant values equals to 0, so then it is for sure that when you put y 0, then x will be 0. So it means that for y is equals to 0, x is 0, so the curve is passing through origin. So if you have to check the intersection of the curve with the origin, and if there is no constant, so it's a direct indication that it is passing through the origin. You could check it by putting y is equals to 0 and x is equals to 0. Both of conditions satisfy each other, then the curve is definitely passing through the origin. Is this clear to you?
Yes, sir.
Intersection with coordinate axis. Uh, Simple. If you have to find out the intersection of any curve with y-axis, then simply do what is y-axis? What is the equation of y-axis? It's a straight line. It's plus y minus y plus y minus y plus x minus f. So here one thing is common throughout y-axis, that x is equals to 0. So this is the equation of y-axis. And for x-axis, the value of y is 0, right? So this is the equation of x-axis simply. So if you have to find out the intersection point of the curve with x-axis, then put y is equals to 0 and solve equation for x, and vice versa for this. If you have to find intersection point of the curve with y-axis, then put x is equals to 0 and solve the equation for y. You'll have the roots of the equation will give points of intersection with y-axis. Okay, and as many roots will be there, and there will be same number of intersection points with y-axis of the curve. Are these 2 points clear? Any doubts?
Yeah, clear, sir.
So now let's understand area of curves into the graph. So we have discussed this also earlier, that if we are integrating any function with dx, so what we are doing exactly is that we are taking a smaller slits of x in this direction like this, and we are summing them up, okay, from some limit to some limit. Here in this case, from a to b we are doing. And in this case, what we are doing is simply we are finding the area under the curve. So if we are integrating them with respect to x-axis, so we are going to look at the area under the curve to the respective axis, which is x-axis. So the area under the curve with respect to x-axis. Now for this graph particularly, we are seeing the area under the curve with respect to y, because we have integrated it with respect to y. So please, I want you to observe and absorb from this picture and understand the nuances. Clear? Any doubts?
Yes, sir.
So same. Now if we have some curve like this, there are two curves. We have to find the area between these two. So what we'll simply do, first we'll take the area of this and of this curve y is equals to fx, and then we'll subtract the area of y is equals to gx. The remaining will be your shaded region. Simply we are first integrating f of x, then subtracting the remaining the area remaining. Sorry, the subtracting the area under the other curve. The remaining will be your the area which is required. So I hope this is clear to you. Good. Is this clear?
Yes, sir.
Yes. And same goes for this. We are doing it with respect to y now this time. First, we are calculating this area here, and then we are subtracting this area. So that's why the remaining area is our answer. Clear?
Yes, sir.
Okay, please observe. So this is our graph, and now we have to find the area bounded by. So we have already we have simplified it in this version by x minus 1 whole square. So from this we get to know that this is a parabola, and if we just compare it to this general equation of parabola, we come to know that the a is 1 by 4, y is y plus 1, sorry, y minus 1, and x is x minus of 1. So y plus 1 is our y, and x plus 1 is our x, small x. So the original parabola, which is this, let's draw the parabola of this equation. So for all values of x, y was coming out as negative. So the parabola will be drawn like this, facing negative of y. है ना? Is this clear, everyone? We're just focusing on a very simple case. We have drawn the parabola of y, sorry, x square is equals to minus of 4ay, where we have taken all the values of x. That's why the parabola is expanding from minus x to plus x. And for all values of x, y is always y is always negative, and it is also touching the origin. But in our case, which we have here, okay, the x is uh, moved plus positively 1. positively on one side, positively by 1 unit. So let's move the value of x by positively 1. So positive x is this side, right? Let me write first. So this is 1, this is plus 1, this is minus of 1, this is minus of 1. So if we have to move our own x-axis positively, so this is the movement. And also in y, there is a positive 1 movement. So the curve will be somewhat here. Okay, and I have not drawn it properly. Otherwise, it would have also crossed the origin. It will have passed through the origin. Let me redraw it using other pen. So the curve on putting x is equals to 0 and y is equals to 0, we found out that it is passing through the origin. And this is one point. This is another point where the whole parabola will open up. So it will be like this. So now, did you understand how we have to draw this graph? And now after doing this, we have simply got to know that the area which we have to find out is this area which is bounded. Otherwise, earlier what was happening, our area was not even getting bounded by x-axis. So nikal lo kya nikaloge? Infinite area. Right now, this is the right representation of the curve, and this is the area which we need to find out. Now the equation of this graph is known to us, that is y is equals to 2x minus of x square. Now if this is the curve's equation, so we can like add up the small slides on x-axis. So we can differentiate it with respect to x from limit. So if now on this point we know that the y-axis, the y point coordinate is 0. Now we have to find out the coordinate of x. So we have the function curve y is equals to 2x minus x square. We know y is equals to 0. So putting y, we need to find out x, 2x minus x square. So 2x is equals to x square. Whether x can be 0 or x can be 2 for this to satisfy. So here x is 0, y is 0, and now x is 2 and y is 0. So now we have to find out the area under this curve from limit 0 to 0 to 2. And that is the importance of finding and tracing the curve successfully to find out the limit, because there was no limit given to us and we could only have find it out using and tracing by tracing the graph. Now is the example clear to you?
Yes, sir.
So let's move ahead with the calculation part. Now x square minus x cube by 3, 0 to 2. Putting 2 first, 4 minus 8 by 3, minus of 0 minus 0. So basically taking 3 common, LCM 12 minus 8, 4 by 3, square unit is our answer. Now let's see if matches our option. Option number B, check answers. Yes, answer is correct. So now I guess you are able to understand the question clearly and also the silly mistake which I did. Let's discuss the next question. Was the previous example clear to you, everyone? Looking at the equation of the curve, we know that this is also an equation of parabola. So representing it in better way, x square minus 1. So representing it in this manner. Now we know this is the equation of, okay, let me draw a smart some parabola. So this is a parabola. Now in this case, for all values of x, y would always be positive, so it will face upwards, and it is also touching the origin. This is a parabola. It's touching the origin. Okay. And now in this equation, if we on comparison, we have find out that x is equals to x. Sorry, the capital X is equals to x. Capital Y is equals to y minus 1. So y is shifted by 1. So let's shift y positively by 1 unit. Okay, we have done so. So now we have drawn the like the parabola's graph, the area of region bounded by the curve, and y is equals to 3. So what is the straight line y is equals to 3? Can anyone tell me what is, if this is the straight line, so where will be y is equals to 3? Please unmute yourself and speak. Please tell me where will be y is equals to 3? Anyone? Y is 3 here, and y should be 3 all the time. So the equation of straight line would be this, would be parallel to x-axis, expanding like this. Okay, so this is the equation of straight line, y is equals to 3, and the area bound in between these two is this. So now let's find out the limits in between these two. So simply putting y is equals to 3 in this term, that is 2. So x is plus minus square root 2. So here y is equals to 3, x is equals to minus of root 2, here plus of root 2 and 3. Is this clear, everyone? So as we know, let me take the help of the solution. As we know, the graph is symmetrical. I have drawn it a little unsymmetrical because of my drawing skills. So we can just find out the area of this and we can double it. For our answer. Okay. Are you with me, everyone? Yes. Are you slept? दोनों सो गए. Hello, hello. Am I audible? Okay, so moving ahead. So finding the area under the curve, and with, like, let's find out the area of this curve under y-axis, and let's integrate in some the steps with respect to y. So we need to find out the function in respect to of y. So x is equals to square root of y minus y. So we have the function in terms of y, and let's integrate it from this point to this point. This is x is equals to 0, y is equals to 3. This is x is equals to 0 and y is equals to, so if we will put x is equals to 0 here, so y will come as 1. So we are integrating from 1 to 3. Now integration of square root of y minus 1 from 1 to 3 dy. Now we know power will get half plus 1. Same goes for this. Limits 3, 1. Y minus 1 into y minus 1 because raised to power 3 by 2 will be written 1 into y raised to power 1 y into y raised to power half. Yes, is equals to y raised to power 3 by 2. So same goes with it. In this case also 3 and 1. So 2 by 3 is putting 3 first. 3 minus 1 2 to square root of 2 minus putting 1 will make it 0. So 4 root 2 by 3 is our answer. Let's match it with the option 4 root 2 by 3. Have we done any mistake? 3 minus 1. So that's become 2. 2 root 2. 2 into 2, 4. 2. Let's check for any mistake. Yes, yes. 4 root 2 by 3 is the just the area of this. We have to double it. So 4 root 2 by 3 into 2, it will become 8 root 2 by 3. Option number A is the correct answer. Is this question clear to you, everyone? Please respond. Okay, shall we conclude our class now? Okay, am I audible? I'm having doubts.